Thank you for coming. Welcome for Hack in Paris. My name is E Litvinov, and I would like to talk to you how BMS may destroyed by smart button. A few words about me. I work at a JS Lab company. I search different security issues in our product. Before that, I spent time to program industrial control system, program PLC, also look security questions for industrial control system, and took part for smart home project. In my presentation, I talk what is it BMS, introduction the KNX. Ideal word, it means what the organization KNX suggests to protect for cybersecurity attack and what happened in reality. Before my talk, I would like to ask some questions. Maybe somebody listened to the news when hacker locked the door in the hotel in Austria and nobody can enter or exit from the hotel and his room. Or other news when the hacker shut down the heating system in the building in the winter. What is it BMS? BMS is a building management system. It is a very huge system to realize function for automation. Usually it is possible divided for several levels. On the bottom level it is a sensor and actuators. For end user, it's usually some smart button or some movement detector or climatic station or something else. Next level is automation level. This level gets information from sensors and send command to actuators. For example, when you set up the heating system, that when I come to home at 6 o'clock, I would like to 25 degrees because it means comfortably. And the top level of building management system, it's management level. For example, big boss would like when his employee come to the work, or how big boss should pay for electricity because power statistics are collected. And the KNX cover bottom two level, and I will talk about this technology and his weakness and vulnerabilities. What is the main objective of building management systems? Firstly, it is reduce power consumption, comfort operation of different systems, and we don't forget that it's comfort for us, for visitors. And usually to build building management system, use a lot of different technology. The main technology is BACnet. Other technology used for field level, however, sometimes may be exceptions, because we can buy a lot of different sensor actuators, program logical controller for KNX, for example, and realize all system use single technology, but sometimes it's maybe very, very expensive. KNX we can meet for some few buildings like Asia Square, Almartown International Airport, or Welt Museum. As I said, for end user, more clear understanding, it's maybe a transponder reader in your hotel when we come after the conference, or room thermostat, indoor presence detection, a lot of other different nodes. Nodes, I mean sensor, actuators, and something else. For example, ABB company provide interesting solution for KNX hotel automation. Interesting because we can see that transponder directly connect to KNX network, and this transponder may lock or unlock the door for hotel room. Now I would like to talk more deeply about KNX technology. To realize this technology, used the two main physical media like KNX Twisted Pair or KNX TP or KNX Net IP. Also, you may find KNX RF and KNX Powerline, but these two technologies are not so popular. The speed limit is presented on this slide. Common questions when the owner will make automation, it's the quantity of node which may be presented for KNX network or ZigBee network or other network. So KNX suggests up to 15 areas. In each area, maybe up to 15 lines, and in each line up to 255 nodes. It means one smart button, it's one node, one actuator, it's another node, and up to 255 nodes. Now I would like to say a few words about how the node communicate in KNX network. You can see that the logical zero presented by changing voltage on the line, and the logical one is no changing on the line. And this is a common structure of KNX frame which sent from one node to another node. So the first byte is control byte. It describes the priority of the frame and shows this telegram repeat or not. The next 2 byte is source address, and next 2 byte is receiver address. And the structure of receiver address, it depends from the integrated solution. And interesting moment, there are a lot of documentation, it's good, but sometimes this documentation conflicts itself, because you can see for one sentence says if you want to use group address, use the DAF bit to 1, and a few sentences later you can see that for group address DAF bit should be set to 0. The next 8-bit is describes the length of KNX TP frame, routing counter, and how to detect this message group or individual address. But I spent a few cups of coffee, because when I use KNX net IP and KNX TP frame and communicate via IP gateway, there are some interesting moments. About this moment, I will take a little bit later. Finally, there are TPCI and APCI field, which describes the commons in KNX frame and how to detect the frame. Is this frame a command, or is this frame data? And he presented the common APCI command, and you can see for me and for us, I hope it's very interesting that there are some commands like read memory, write memory, user message command. As I said, usually also use KNX net IP. To do that, KNX TP frame packet to semi message and send via UDP datagram. And here presented second control byte. This byte take me a lot of cup of coffee, because in the documentation you can see that this control byte describes the routing counter and group or individual address. But when we use IP router, the second control byte added, and we should select and parse this byte, not first byte. Now I will talk about a few words how to, in ideal world, buy KNX. A few years ago, the main recommendation of KNX organization was hide the wire communication and don't worry, because the wire is hidden and nobody can hack your building. But it's not good recommendation. And now the white paper for security position became better, and there are some mechanisms which provide security communication. Also, there are good user guides how to security commit node, use the private key, and protect your systems. And ETS software also provides some security feature, like security IP communication. However, it's ideal world, and we live in reality, and not so good, because when I tried to add the modern IP router to ETS software, I received this message that, sorry, you use IP security communication, but this device don't support this feature. It's new device which not support this device, which not support the security feature. The other pictures, I hope you recognize this. I hope you recognize this print screen, because it's showdown sensors and other global search, and we can see that there are a lot of devices which connected to internet. It's a lot of different KNX device, and we can sometimes manage this device. So before look the attack surface, we should decide two questions. First, how to connect to KNX twisted pair. It is possible to use standalone device, or design some transceiver use smart transceiver, or in my case, I design self transceiver based on analog elements. The next question is how to work with KNX network, how to configure. So if you have approximately $1,000 or less, you can buy the ETS software. Then you need press button to switch into program mode any node. And sometimes to do that, you need go to the attic of other building for press button. And after that, you can commit, configure node, and enjoy. But I don't like easy way, and I try write small tools. My tools allow to connect to KNX network via Ethernet using IP gateway, or also I use ESP32 microcontrollers to connect via Ethernet or Wi-Fi, or connect directly to KNX twisted pair. The main feature of this tool is sniffer traffic, scan, node, read, write, and set key authorization. We get answer for two common questions: how to connect and how to manage. So if attacker connect to KNX twisted pair anywhere it means smart button in a hotel room, or climatic station in outside secure perimeter, he can get basic information about node. He can listen the traffic and also understand what happened in the network. And no problem to realize replay attack, because just take the telegram, replay, and you have success. So we discover the area or segment where an intruder connected. After that, he can just manage any node, because the protocol is simply, and there are no any security feature to send the datagram between the node. And we hope that integrators was good guys and make the segmentation for example, for different floor. And the attacker finds the IP router which lock. It means that this router don't transfer the telegram for other network, and we have the segmentation. But we can use the command read memory, and we get all network settings, and look how this router lock or unlock. After that, we use command write memory to change the configuration. We can change network settings, we can change his status, and we can unlock the router and discover other segments. After that, we discover and may manipulate, change config, destroy something, or broke connection between, from example, press button to switch light, and broke this connection. Moreover, there are some nice features during my research. It is API commands user message. As you remember, the standard says that the length of KNX-TP frame may up to 15 bytes. However, some routers allow transfer up to 69 bytes. The next thing is that for some router, we need to use pad or padding because when you send the KNX-Net IP frame to KNX network, and if this frame less than 16 bytes, the IP router don't transfer this frame. Also, you remember that IC, if you use ETS software, you need press button to change the configuration. In fact, this action no need because just use command read memory, write memory, and you have success. And interesting future key authorization. The KNX standards says that this key used for memory access protection. However, you can set new key, the node confirms that, yes, I received new key, it's OK. But after reboot, nothing happened. You can use all the key. Now, let's look how the attacker may prepare the springboard to penetrate the corporate network or operation technology network. As you remember, he connects anywhere for KNX-TP line, broke the segmentation, and finds the router which may upgrade firmware from field side, I mean from smart button or other end devices. After that, the intruder may update firmware for other router. So I hope you have questions how it is possible. To update firmware from field side, just use API command user message with additional command to read firmware and write firmware, additional code presented on this slide. And how to get control the other device. To do that, there are some difficult steps like connect to Ethernet, run a vendor update tool, and just update firmware, no check present, nothing check, nothing integrity check, just updating. Inside the IP router, you may find there are a lot of different microcontroller units from Atmega 120H to some different ARM microcontrollers. This IP router work under Linux OS or custom firmware or NUT OS or the some real-time OS for embedded device. And usually IP router use smart transceiver. Now I will talk about attack surface for automation level. For example, the Lynx 115. It is a program automation station, and this station allows connect for a lot of different protocols and technologies which use to which use in BMS systems. On this slide, you can see that this automation station allows manual control, micro SD card, USB, and Ethernet. There are three ways to connect for this device: serial communication, manual communication, and Ethernet via HTTP, FTP, SSH, and some other protocols. So when you connect in manual, you can do anything: upgrade firmware, downgrade firmware, change settings, enable some feature. And to do that, you need also no password, no any other security mechanism to change it. But I think you agree that more interesting remote attack. So the Lynx 150 have a web interface, and when we open the browser and come to this web interface, we see the basic information. And for guest user, we detect the number of firmware versions, what firmware may be downgrade, also which technology is used. When we use default credential, he presented on this slide, there are a lot of information, and you can do also anything, update firmware, change settings, or do something else. And don't forget that all this communication across HTTP or FTP protocol, it is not secure. And you can see that all web interface have a lot of different attack surface, like SQL injection, cross-site scripting, and something else. So you can see that the length of password may be from 1 symbol to 15 symbols. I hope you agree that 15 symbols is more good password, but I look for firewall rules, and I don't find that IP tables may block brute force. There are no fail to ban SSH guards. So if you miss, you may brute force password, and you also have success of this realization. Little bit step aside, I spent a few minutes and find this interesting node which use the default credential password. And it's not only this device, there are a lot of devices which use default password, and only small information message that when you use default password, the web interface says, hey, you use default password, and continue. More interesting is the firmware for this automation server. This firmware you may download from official website. It's at the first point of view have a magic extension like .dl, but inside this magic extension there are a lot of Debian package with some package from LaTeX. And unfortunately, there are a lot of old package with now vulnerability for this device. Moreover, I look for links AT91 file. It's one of general binary file, and we can see that this file not stripped, and there are a lot of information, and stack may be executed. Also, if you forget if you lose the documentation, don't worry, because the firmware contain hard-coded credential like admin and LaTeX for you, this default password, and you never lose this information because it's hard-coded in the firmware. Also, interesting function called firmware update from file. It's good because this function allows to upgrade firmware, fix some bug, but inside this function there are no any check. Just check that there are additional space to update and update this firmware. I think you look the slide and get smile, because also in firmware was discovered some private key, and as I see, the same private key used for different versions of firmware, and for indirect signal, I suppose that's the same private key used for different devices. Also, I look for more modern automation station called Linux 153, but the situation is, yes, of course, some new specific package for Linux 153, and a lot of old package from the preview generation of this automation station. In conclusion, for additional information for KNX security, you can read and look for this presentation from, for example, for Joseph Malina. He describes that when he visits a luxury hotel, he can manage the lights in a neighbor room, because KNX network and public Wi-Fi is the same network. The next paper describes the extended security for Kinix, but the main idea of this security adds some additional field for security. And the other presentation, which describes some security issue for ZigBee and Kinix. As a conclusion, unfortunately, Kinix network have weakness and vulnerability because it is possible DOS attack, upgrade firmware from field side, manage any node. And if we look for automation station from Litech, it's use old package and use non-secure communication protocols. However, not so bad because the white paper for Kinix security become more better by steps by step, and now it's more better than a few years ago. And some vendors realize this security future, spend some time for security issue in Kinix. Finally, I would like to say the graduate for Dmitry Viktorov, Sensarmatica, and my friend of KISS. Thank you for your attention, and I am ready for your questions.